All right, guys, easy day. Today we're talking about the greatest common factor and working with polynomials. It's something that has kind of come up in multiple homeworks, but never all together. It's like the homework assignment has assumed that you knew this already, but it hasn't ever actually taught it. So I thought now would be a good time to make sure that we understand what it looks like to deal with the greatest common factor and polynomials, because it's something that you're going to use a lot going forward. It might have even been a good idea to do this a couple months ago, but that was a couple months ago. Today's today. So a couple of review things. Greatest common factor. So in a multiplication problem, the numbers that you multiply together, we call those factors. The answer to a multiplication problem is called the product. So in the problem, 5 times 4 equals 20. 5 and 4 are the factors, and 20 is the product. If we reverse that problem, okay, if we say 20 equals 5 times 4, then we say we have factored 20 into 5 times 4. So depending on which way we write it, you read it a little bit different, okay? But the important thing to note here is that the product of two things is 20. The factors are 5 and 4. Those are the two things that multiply to be the 20. Now, greatest common factor with polynomials, okay? If I have a multiplication problem, 2x multiplied by x plus 4, I'm going to have to do, the Santa hat and distribute, and that's going to equal 2x squared plus 8x, all right? So in this problem, the 2x and the x plus 4, those are my factors. And the 2x squared plus 8x, that's my product, okay? If we reverse, if we go the other way, if it gave you 2x squared plus 8x, and it wanted you to factor that, it's kind of like undoing the Santa hat, then your answer would be 2x times x plus 4. So we would say that we factored 2x squared plus 8x into 2x and x plus 4. So the first step to factoring a polynomial, before in class we've been doing this big X method and all these different things, and really what we should be looking for first is a greatest common factor that we'll factor out. I've given you problems that don't require you to do this, but in the future, it might be a good idea and might be necessary that you look for a greatest common factor first. So a couple examples. 5x minus 35. If I were to factor out the greatest common factor, a 5 goes into 5 and a 5 goes into 35. So I would factor that out, I would undistribute it, and I would be left with x minus 7, okay? And the way that I did that is I know that 5 goes into 5 and 35. And to get the x minus 7, I just divide the 5x by 5, and I get x, and I divide the negative 35 by 5 and get negative 7, okay? 3x squared plus 27x. So when I look at the 3 and the 27, I know that a 3 goes into both of those. And then when I look at the x squared and the x, there's only one x in one of them. So I'm only going to be able to take out, whoa, what just happened? That was kind of cool. I'm only going to be able to take out one x. I'm not going to be able to take out x squared. And when I do that, when I take 3x squared and I divide that by 3x, I'm left with x. And when I take 27x and divide that by 3x, I'm left with 9. Because 27 divided by 3 is 9. X divided by x goes away. So I'm just left with a 9. Sometimes you can have more than just x's. In this case, I've got 12x squared plus 12x squared y squared plus 32x y cubed. So I got a 12 and a 32. And the biggest number that goes into both of those is 4. And then when I look at my x squared and my x, the biggest thing that goes into those is x. And then when I look at my y's, I've got a y squared and a y cubed. So the most y's I can factor out are y squared. And when I do that, I'm going to take 4xy squared out of everything. So I'm going to take 12x squared y squared, and I'm going to divide that by 4x y squared. So the 12 divided by 4 becomes 3. The x squared divided by x just becomes regular x. And y squared divided by y squared becomes nothing, just 1. Okay, 32xy cubed divided by 4xy squared. 32 divided by 4 becomes 8. X divided by x becomes nothing. And y cubed divided by y squared just becomes y all by itself. All right, sometimes we have a negative in front, and this is the one we got to be really careful about because I've got negative 2m to the fourth plus 14m. And I don't like to have a negative in front of my biggest exponent, so I'm going to actually, when I look at these things, I'm going to actually take out a negative with my 2. So a 2 goes into 14 and into 2, but I'm going to take out a negative 2. That's where this negative 2 comes from. And then m to the fourth and m, the most m's I'm going to be able to take out is 1. So negative 2m to the fourth divided by negative 2m gives me m cubed, and 14m divided by negative 2m. The 14 divided by negative 2 becomes negative 7. This is written wrong. This should be a negative 7. Shame, shame. Examples doing the math wrong. That should be negative 7. So I should get m cubed minus 7. All right, so let's do a couple without the examples already worked out. So 6x to the 7th plus 15x cubed. So the first thing I look at is the 6 and the 15. And that means I'm going to be able to take out a 3. That's the biggest number that goes into both of those. Then I look at x to the 7th and x cubed. And the largest number of x's I'm going to be able to take out is 3 of them, x cubed. So I got to figure out what's left over. So 6 divided by 3 is 2. X to the 7th divided by x to the 3rd is x to the 4th, plus 15 divided by 3 is 5. And x cubed divided by x cubed is nothing, so it's just 2x to the 4th plus 5. So my final answer is 3x cubed multiplied by 2x to the 4th plus 5. Those are my factors. That's my factored form. Okay? Number 2, negative 10x to the 7th plus 5. I'm going to look at the numbers first. What goes into both of these? Well, I don't want that negative out in front, so I'm going to take out a negative 5 from both of those. And this one has an x to the 7th, but this one doesn't have any x's, so I'm not going to be able to take out any x's. All I'm going to be able to take out is a negative 5. So negative 10 divided by negative 5 is positive 2. X to the 7th, I'm not taking any of the x's out, so that's just left x to the 7th. 5 divided by a negative 5, I'm not minusing, I'm doing 5 divided by negative 5 is negative 1. So my answer would be negative 5 multiplied by 2x to the 7th minus 1. Okay, number 3. I've got a 4, a 12, and a 22. So the largest thing I'm going to be able to take out is, what, a 2? And then I've got an a to the 5th. Oh, I don't want to use yellow. I've got an a to the 5th, an a to the 3rd, and an a. So I'm only going to be able to take out one a. And then I have a b, and a b. So I'm going to be able to take out a b. So 4 divided by 2 is 2. A to the 5th divided by a is a to the 4th. B divided by b is nothing. 12 divided by 2 is 6. A to the 3rd divided by a is a squared. B divided by b is nothing. 22 divided by 2 is 11. A divided by a is nothing. B divided by b is nothing. Well, technically it's 1, but we're multiplying, so it's nothing. So 2ab multiplied by 2a to the 4th plus 6a squared plus 11. All right, number 4. Why don't you pause the video, try this one on your own, and hit play when you think you got it. Okay, so I am going to take 10 out of this, and I'm also going to take p to the third, and I'm also going to take q squared, and I'm also going to take no r's because my last term over here doesn't have any r's, so I can't take out an r. So I'm left with 5p to the fourth q squared r plus 3p q squared. I took out q squared, and I'm left with r, plus 1p cubed came out, q squared. So 10p to the third q squared on the outside, and that mess on the inside. Okay, difference of squares. We love this shortcut. If I have two things being multiplied, if I have two things being subtracted, and they both are squares, then I get this really cool formula right here. So if I have a squared minus b squared, I end up with a plus b times a minus b, all right? And I'm gonna show you just a bunch of examples really quick, okay? If I have x squared minus 9, that is the same thing as x squared minus 3 squared, so I can rewrite that as x plus 3, x minus 3. If I have y squared minus 64, that's the same thing as y squared minus 8 squared, so that becomes y minus 8, y plus 8. If I have 25x squared minus 81z squared, that's the same thing as 5x squared minus 9z squared. So that becomes 5x minus 9z multiplied by 5x plus 9z. Okay, so it's a really cool pattern. So when I look at these problems, k squared minus 100, well, k squared is just k times k. 100 is 10 times 10. So I can rewrite this as k minus 10 and k plus 10. Okay. Number 6, 9x squared. Well, that's just 3x's times 3x's. And 25 is just 5 times 5. So I can rewrite that 3x minus 5, 3x plus 5. Okay. Now, a squared minus 121b squared. Well, a squared is a times a. 121b squared is 11b times 11b. So I can do a minus 11b times a plus 11b. 16g squared minus 81h squared. Well, 16g squared is 4g times 4g. 81h squared is 9h times 9h. So I can rewrite this 4g minus 9h multiplied by 4g plus 9h. Now, guys, be careful. If I had x squared plus 36, this is x times x. This is 6 times 6. But I do not have a minus in the middle. It doesn't work. It has to be x squared minus 36, and then you could do x minus 6, x plus 6. If it's not a minus, it doesn't work. Also, if I had x squared minus 30, x squared is x times x, but 30 is not anything squared. It's not 5 times 5 or 6 times 6. It has to be the same number times itself. I can't say 5 times 6 and then write x minus 5, x plus 6. That's not how this works. It has to be the same number multiplied by itself in order for it to work. So be really careful. On the homework, flip the page over. The homework is on the back. I want you to do all of them. There's only 19 problems. I think you can handle it. Submit it on Canvas when you're done.